Here is a numerical type question. Work through the numbers carefully. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the substrate and reagent. The substrate is trans 1-bromo-3-methylcyclohexane. The wedge on CH3, C1 up, and the wedge on Br, C3 down indicate a trans 1-3 relationship. The reagent is CH3O, a weak nucleophile and weak base, so both SN1 and E1 pathways are operative. Secondary carbocation can form after ionization, or the reaction can proceed via SN to E2 under the solvent conditions. However, CH3O as a protic polar solvent with no strong base nucleophile favors SN1E1 at a secondary center. Step 2. Reaction pathways available. Because CH3O is a weak nucleophile and weak base, and the substrate is secondary, we consider SN1E1 and also SN2E2, since secondary substrates can undergo both. However, the key analysis is what distinct constitutional and stereochemical products are formed. Step 3. SN2 pathway, backside attack by CH3O on the C-Br carbon. SN2 inverts configuration at C3. Starting material is trans, CH3 up at C1-Br down at C3. SN2 gives inversion at C3 placing OCH3 up at C3. Product has CH3, C1 up, and OCH3, C3 up, CIS-1-methoxy-3-methylcyclohexane. This is one substitution product. Step 4. SN1 pathway, carbocation at C3 then attack by CH3O from both faces. Ionization gives a planar carbocation at C3. CH3O can attack from either face. A. Attack from the same side as CH3, top, OCH3 up at C3 CH3 up at C1 CIS-1-methoxy-3-methylcyclohexane, same as SN2 product. B. Attack from the bottom OCH3 down at C3 CH3 up at C1 trans 1-methoxy-3-methylcyclohexane. This is a second substitution product. So substitution products, CIS and trans 1-methoxy-3-methylcyclohexane is equal to 2 products. Step 5. E2 elimination pathway. E2 requires anti-periplanar arrangement, H and Br anti. The beta hydrogens available are at C2 and C4, adjacent to C3 bearing Br. Elimination toward C2 gives 3-methylcyclohex, 2-Na, a trisubstituted alkene. Elimination toward C4 gives 3-methylcyclohex, 3-Na, which is the same connectivity as elimination the other way, i.e., 1-methylcyclohex, 3-Na, 3-methylcyclohex, 1-Na. For E2 with a cyclohexane, the anti-periplanar requirement means the H must be axial and Br must be axial simultaneously. The transdiaxial requirement determines which elimination products form. Considering the two possible beta carbons, C2 and C4, the double bond can form in two directions giving to regioisomeric alkenes. A. 3-methylcyclohex, 2-Na, endocyclic double bond between C2, C3. B. 3-methylcyclohex, 3-Na, 1-methylcyclohex, 2-Na, double bond between C3, C4. These are two distinct elimination products, constitutional isomers. Step 6. Count total distinct products. Substitution, 2 CIS and trans-methoxy products. Elimination, 2 regioisomeric alkenes. Total X is equal to 2 plus 2 equals 4. Therefore, the correct answer is 4. Therefore, the correct answer is 4.